Hi, thanks everybody for coming. The next presentation is from Clement Escoffier from akquinet, based in Berlin, and it's going to be about continuous delivery from dream to reality. Thanks.
Thank you. So, hello. I'm Clement Escoffier. I'm working for akquinet. It's a German company based in Berlin and in Hamburg. But I come from Berlin. I just have a couple of questions first. Who comes from the Java world? Who comes from the PHP, Rails? A bit. Okay. So I work since 7 years in what we call modular software. So it's software that we divide in small pieces because we are thinking that it's more easy to develop. But actually it's much harder to build and to deploy. And during my experience, I see a lot of evolution in the build processes. I saw Maven 1, I saw Maven 2, a bit better. I saw Maven 3, all right, okay. And it always has a weird, I always had a weird feeling about those tools because actually it really makes a difference if you are a developer or if you really want to deploy something. So what I will describe and discuss today is based on nothing real. It's just from my experience. So if I work for you, no. So I will just tell a story which is more or less you can realize that you are more or less inside. Well, as an example, I will take a project of a regular size. So your project might be bigger, smaller, it's not really important, but this is a use case which is quite common today. So running for 2 years, not that long, but well, 2 years in software development is not that bad either. 6 developers, so perfectly fitted for Scrum and Agile development. It's Java-based. We'll see the tools that they are using on such kind of project, but yeah. And when you see such kind of project, the build is chaotic. So what does that mean? That means that somebody which is arriving and try to understand how the build is working, not the software, just the build. Or to build the software, or to get it running, or to see what changed, or it can contribute something, it will just take 1 or 2 days. Well, actually, it's kind of weird because the build is not the business logic of the system. You should be immediately ready to write some business code, not spending time to do that. But yeah. So what I name chaotic, and here you will maybe recognize your project. Taking forever. 2 years ago, if we take a quite famous project, Glassfish, if you wanted to build it from your computer, it was taking 2 hours. That's quite a lot. Intermittent failures. Everything which is asynchronous and so on, and you always have, oh yeah, your computer is faster than mine, so you will have to add some thread.sleep or wait or whatever. This is horrible, because it's definitely not reliable. I saw so many projects where on the developer machine and on the CI, they use different parameters because the CPU is different, or the memory is different, or the bandwidth is different, and so on. Inconsistent output, that's the last thing. You have a build, especially in the Maven world, it's so famous. You have a build which depends on snapshots. We will discuss that later. So it's today, I build, I get one output. It's tomorrow, I build, I get something different. I didn't change anything, but I got something different. Because somebody has committed and it's deployed on another repository and so on, it can change a lot of things. And you don't know because, well, you was working on your feature and now nothing is working again. So that's also the non-reproduced build issues. And the last one. The last one is probably what takes me today the most part of my time, authorization failure. There is so many differences between the development, the continuous integration system, or your production system that you always have some logging fail, cannot access resources, or blah, blah, blah. So your Maven repositories you don't have the good credential, you cannot commit because obviously your CI doesn't have the right credential to push something on your Git repository or to commit something in your SVN. So all those issues. So, and one thing when we are working in projects, you need to release. At one point of time, your customer or your company say, well, no, it's time to get something live and to sell something and to get money out of that. Well, actually, releasing is involving a lot of stress in the software development team. It's because, well, you cannot delay anymore, you cannot postpone, you really need to have something working. And the delivery generally really error prone. Why? Because your development environment is probably pretty different from the production environment. Let's just say the database is not the same. They are using Oracle, you are using Postgre or MySQL. So such kind of difference can really matter on big systems. So it involves delays, a lot of delays. Well, delays doesn't make the customer really happy. The unsatisfaction is rising. The customer comes with bugs that you fixed two weeks ago and you cannot reproduce and so on. So it's bad for the team because they have a lot of pressure. They release something that was not really ready. The customer gets delays and so he's not happy and so on. So the next step is pretty simple. The trust failed. Your company, your boss and so on start thinking, hey, why are you not done? The estimation was 6 days and you spent already 10 or 15 days on this. As the trust failed, we had more pressure on the development team. So, what we remove when we have pressure in the development team? We remove the tests. That's the first thing that we dropped. Well, who cares about testing, actually? So, we reduce the quality of the test, the coverage, and so on and so on. And so the technical depth increase. So that means for the next iteration, the next evolution of the project, the maintenance will cost more money. And you don't want to really develop anymore on this project because you know that some parts are broken per design. But why? Because at the beginning you was just trying to release and to deliver your software. That's kind of weird. So I saw that in my career at least 3 or 4 times a month, such kind of situation. So we reach in something that I call non-optimal project situations that we can summarize by it's a big mess. It's a big mess because your software that you have developed is not the quality you would like to have. You have delays, your customer is not really happy, or your company is not really happy. So we had pressure and so on, so it's not a sane environment to develop a good software. And what we are doing here, and we all want to develop good software, which is cool, using good technology and so on. So, once upon a time, a little bit later, there is something called escalation meeting. So all the Thai people are meeting in a room and just say, yeah, well, we need to find a solution, blah, 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 you have promised me this and I don't have that. So at the end of such kind of meetings, they just say, hey, let's deliver a version every day. That's interesting. Because before we was delivering a software every 3 months, 6 months, well, it depends on your settings, but well, and here, because we want to restore trust, because we want to fix all those issues, we will make the issues even more bigger. We want to deliver every day. Whoa. So, okay, but what do I mean by delivering? So it depends on your context. If you are in a web app, Java EE, well, you can immediately see an up and running system that you can check. It's maybe your production system. I speak about delivery, so it can be production or not. It's up to you. In mobile app, it's generally downloadable or in a market. Can be Android market, your own custom market, or Appsula, for example, or anything. Or well, with iTunes, with Apple Store, it's a bit more tricky because it takes 2 weeks. But yeah. Or for desktop application, you may want to provide an installer or a market. No, it exists too. Or an auto-update mechanism where it will automatically update something and so on. And everything installed on a system. So in addition of the software that you was trying to develop, we had some more complexity. Because this is not easy to get. So when you, after this meeting, when the next project management, project meeting, the developers say, well, that means 1 release a day. They are really not happy. So who is using Maven here? Oh, not that much. Who has never encountered any, from Maven user, any release issue using Maven. As a release, so Maven define as a plugin for releasing. So they try to have a process which is quite interesting. So they get the software, they increase the version number, they run tests, they create a tag, and then they create the artifacts. So it's quite clear, quite clean. It seems simple, but every time I have to do a release, something gets wrong. Every time. Yesterday I found a bug in the latest 2.3 version on Maven 3.04, so just yesterday. Whoa. So more release is not good for developer. While the project manager, for them it's more paperwork. Yes, they need to go to the bug tracker to check every day what it's done and so on, so they are not happy. And for the production guy, they say, well, it's more changed. Before he was providing one binary every 6 months, and now it will be every day. So every day I need to do my manipulation, copying, the unzipping, and so on. Yeah, no, that won't work. So that's a challenge. If you're in such kind of situation and we say, well, we really want to have continuous delivery, it will be a seamless disruptive change. It's pretty hard to convince people to say, hey, let's do that correctly. But at the same time, it has a lot of advantage and we'll see them. So, first, how to introduce continuous delivery. This quote is from one of our project managers. He decided, yeah, let's all commit to a continuous delivery model where every commit will go in production. That will be so cool, and so everything will be automated. But what's changing? The way we work. And that was the hard part. So that means we have a team, this team, no, for 6 people. They don't want to change absolutely nothing on how they are working. So that means developing on their own system, committing to the same SVN, not version change and so on, and definitely not doing a release every day. So that's hard. Let's define some principle in continuous delivery, no? Who has already implemented it? Or at least for a try or something? Nobody? 3? Okay, who knows at least, who already read about it? It seems to be a kind of buzzword right now. It exists since 1995, so it's quite old. The first reference to something close to continuous delivery was at least in 1995, and there is probably things close to that a long time before. So, the first idea of continuous delivering is to understand what are the delivery anti-patterns that we are all doing for years now. Manual software building and deployment. You are running the build, or you have a release manager, and this release manager is cutting the release on its own laptop. Apache. The Apache Software Foundation is promoting this model. So each project, or so depend on the project, but for example in Apache Felix, we have a release manager per component, and when we cut a release, the release manager cut it on his laptop, upload the artifact to a repository, okay? And then we do some voting and stuff like that. And then we close this repository and say, hey, okay, we have the release. But the interesting thing is that we're copying those artifacts to another location. Nothing avoids that we modified something in those artifacts. And we already saw that a couple of times that some Apache projects have broken releases, even if they was tested and so on. So manual software building is not a good idea. Deploying in production, or in production-like environment, only after releasing. That's probably the hardest part, because we don't have access to the production environment when we are developing. And that makes sense, because, well, we don't want to have access to the production database. The important thing is it's a production-like. Is to have something as close as possible and to be sure that all the differences are not important or are not impacting your software. Finally, the configuration and of the environment. Well, if you are, when you develop or when you deploy your system, if you have to connect on your host using SSH or whatever, editing some configuration file, this looks bad. At least it smells pretty bad. Because that means that somebody will, in the next release, do exactly the same thing, but probably may not have the knowledge, or whatever. So if you are quitting for this team, or if you are doing something else, then somebody else that will do all those manual steps, and you can be sure that something will go wrong. In a project from my company, I saw somebody on the Sunday afternoon trying to fix some host file on a production system. Well, it's a Sunday is good because the customer is not there, so you cannot see it. Well, that's interesting. Anyway, continuous delivery, well, it's pretty simple. We just want to have some process which will take the current source every time, after every change, and we try to build the software and make it working and deployed somewhere. So, or delivered somewhere. So, for a web app, for example, it will be a running system that you can check, that the customer can check. It's really interesting for teams where you have a version and you are working on your features and you can immediately see that your features is working in production. For the motivation, it's really good. You really see that. For the customer, or for the people for who you developed, it's good too because you see that you are already working and not spending time behind on Facebook or Twitter or whatever. You see the change live. So the overall idea is to simplify software delivery. And the keyword is automation. Others, responsibility, because it's a responsibility from the developer to commit to this model and to just say, okay, if I push something or if I commit something on the trunk or on my source repository, this something will be seen by somebody else. So if you just have a system out, or even worse, on a web page where you just say blah, or to do, or something like that, that means that this to do will be seen by somebody else. So you generally try to avoid typo or stuff like that. It's an interesting way because you say, well, it's more responsibility, and I don't want to have, as a project software developer, more responsibility. But actually, this is accepted pretty well. And the pipeline, so we will explain what is a pipeline later. So, but the real keyword is automation. You need to automate absolutely everything. And you can say, well, but some parts are hard to automate. I come from the Java world, so I cannot really tell about PHP, Ruby, and so on. But at least for web app, or even for desktop app, you can mostly test everything. You say, well, UI? Well, you can test UI. There is, for desktop swing, you have a fast swing, something like that, where you can really make clear that everything works. For web app, you have Selenium. Okay, people doesn't really like Selenium. But you have Jeb, which works pretty well. And so you have a lot of frameworks which are available today, which are easy to learn, to test mostly everything. Capacity and so on, or performance, then look at what Gmeter is doing, or Gatling, and so on. So that you have tools for that. So automate everything. That means, oh, okay. Bootstrap, configuration, all your tests. So that means unit, integration, acceptance, UI, capacity, performance, smoke. Every company has its own vocabulary, so I try to cover most of them. Automate your release, automate your deployment, and for people using database, your evolution. And that's the most hard, today the hardest part is this, in case of rollback. But we will come to that later. So the second big point is the pipeline. So a pipeline is this. I think it's one which is now arriving in Germany, the Nord ones from Russia to Germany. So it's a wire, it's a pipe like that, where we will do several steps, so first step, second step, and so on, and so on, and so on. And you cannot shortcut. That's pretty important. You cannot go from here to here. You have to go through the complete pipeline. So, pipeline. A pipeline in software development, at least this is a simplified version. It will look like that. So it will be a process where we start here. So you are a developer. You are working on a project. You commit. And then you will have something automated, which will take what you commit and will test it. Will run unit test and package it. Generally, what you have at the end of the commit stage is a package that you can use for all the further steps. So then you can do the acceptance test, the UI test, the deployment test, or in other order, it depends, capacity test, and at the end, release, and so on. So that means that every steps will be automated, and we will do them in the right order. But don't forget something. Even if we are developers, it's not only source code. Source code is just 1/4 of what we are doing. We have the source, we have the data, we have the configuration, and we have the environment. So everything needs to be handled by your pipeline. If you consider that your pipeline is done as soon as you have all your source to a package, you are missing something. So data will be all your test data or your provision data if you are running on a system which is from scratch. That will be here. All the configurations, Apache configuration, your database configuration, all your users that you need, like your application is probably not running as root or whatever. Everything needs to be described. And environment will be mostly the same thing. Configuration is more application specific, where the environment will define, okay, you need this package, you need these services, and so on. So you will need build tools, and you will need a build process. So in build tools, there is plenty. Make. We have Ant, we have Maven, we have GCC, and so on. So it's compiler. All of them are quite good. Even the newest one like Builder, SBT, Gradle, you can do what we will explain right now with those tools. I come from the Maven world and I contribute a lot to Maven, so I speak more about Maven, but yeah. The important thing is you need a process. And this process needs to be clarified with all your team and all people that will participate and saying, okay, it's how it will work. It's not only, well, we will package. It's the package, the tests, the different phases of tests, the release process, the deployment, and so on. That's pretty important to cover everything. So, first thing, checking everything. You are writing something, a script, inside the SCM. You are adding a picture for test, add it to the SCM. Well, before, 10 years ago, 15 years ago, they will say, yeah, the disk space and so on. Well, come on, today the disk space is so cheap that you can checking everything. Right now I'm working on a project where we have all our pictures, documentation, everything is inside our SCM. And you can't believe how good it is to say, where it is? Well, I know. It's always at the same place, it's inside my SCM. So in that case, it's inside my Git repository. So I know that I have absolutely everything. I know that I can always find what I did, and people of my team or the automate that we are building can get it. So everything means source code, deployment script, data, database evolutions. So if you are using liquid base, for example, configurations, environment descriptions, and build script. So here, all your configuration log and so on. Here, if you are using tools like Puppet or anything, then it will be here, and all your build scripts. Something important is the traceability. That means that you need to be sure that your process will generate something that you can reproduce. Why? Because don't worry, continuous delivery does not eliminate bugs. So you will have bugs, for sure, and you need a way to reproduce them. If you start implementing continuous delivery and your build is not reproducible, that means that if you take a specific revision of your software, you cannot reproduce exactly the same artifact and the same bug, then something is wrong. So for Maven users, that means no, snapshot is something that you need to forbid. Well, but I said just before, we must not change the way where developers are working. Ah, okay, so we'll come to that later. So unique versioning, human readable, because I got Git version are not human readable. That's it. it's a SHA-1 and so on, that just, poof, they're too complex for me. Having tags for everything that you can really trace and see who has done what. Notifications, something went wrong, get a notification. It can be what? IRC, mail, Jabber, phone call, or whatever. For example, in companies in Boston, they are sending text message. That's interesting, at the middle of the night. But yeah, well, it's what they are using. It must be introspectable, so you go to your live system, you need to know exactly which version you are using of everything. So just before coming, I saw a demo of YAD. They are in the exhibition room. They have this. You see exactly the version of what you have. And it must be reproducible. Second big principle, continuous integration. So who is using continuous integration? I hope that I will have good. Yeah, okay. Jenkins, TeamCity, Bamboo. Oh, somebody has tried Travis? Okay. So Travis is a new one. I never tried it, so I have no idea how it works. Okay, so he's on the team. So the continuous integration in continuous delivery is more or less the cornerstone. So the first idea, you automate everything, and you have one thing that will be responsible about everything is this. So it will be a Jenkins or whatever instance, probably more, well, but it will do and execute all your process. So we will find some pattern like commit often, avoid branches. That's weird. Use branch by abstraction. Ooh. Avoid branches, why? Because what you will deploy, except if you have unlimited money, and you have unlimited production host or QA host or whatever, then you probably will integrate and deploy only one branch. So if you start having 10 branch or whatever, only one will be correctly integrated and deployed. So it's kind of bad. So we are moving in a model where we have one main branch, trunk, master, or whatever. You have feature branch, but those feature branch are short. Well, their life is short, so no more than 3 to 5 days. And actually, a real rules is more time you spend in your branch, more time you will spend to merge it. Because if you are in a team, except if you are alone in your team, then it's okay. But if you are working, even if you are two, then you can be sure that something pretty bad will happen while you are working on your branch, and then the merge will be complex and so on. So one pattern which is developed, which starts to be quite used now, it's branch by abstraction. That's interesting because it has nothing to do with branch. Branch by abstraction is, well, we will add some indirection to make a refactoring hidden. Let's say, the basic example, you have Hibernate and you want to switch to Hibernate. Well, all new entities will be in Hibernate, and as soon as I touch one thing, I will migrate to Hibernate, but from all the other layers, I should not see anything. We don't change the signature, we don't change anything. So it's in terms of design pattern, it's a lot, it's facet, strategy, and so on. But it will start working quite well, and in big projects like Apache Felix, we are using that since 5 years, and we never had any issues. So we only have the trunk, but we try to make it clean and clear, and it works quite well. So we avoid disruptive change, actually. So in the second half, we have comprehensive tests. So test everything, make them understandable. So if you have some project where your tests are named test A, test B, test 3, that's not good. Actually, for that, we now have something called behavior-driven testing, Jasmine or gbehave or whatever. It's Cucumber. It forces you to write some more documentation in your test, because you will have to write some sentences and so on. It's really good. It's really good because you see that everybody can understand your test and at least actually know what is broken. 2 weeks ago, I was on a new project. I did some stuff. Obviously, I break something. I break everything every time, so don't give me a project. Well, the test that was failing was test 3EZPFF, something like that. I was really happy with that. I had no idea what it was meaning. Actually, it was a GNI issue that I was not loading the right library. If it was a test that the Java library can be loaded correctly, that would have been so simple, and I would have checked that I would just miss one flag when I was executing the test, because I'm using a Mac. No, I spent 2 hours to try to understand what this name was meaning. So just this. And fast feedback is the last point. If you have a test suite which take more than, I don't know, 6 hours to execute, that's kind of bad. Tricky thing is that you need to think that until you commit something, until you get a mail saying, hey, everything is fine, your mind, you cannot really focus on any other task. We are human and we are all like that. So we are always waiting to say, oh, I cross my fingers that I didn't break anything. And so faster is this feedback, better it is. Even if it's not a complete feedback, like, well, you didn't forget to add any file inside your SVN. I did this mistake on, yeah, on Apache Felix, you will check my last commit, it's forgot to add a file. So that was exactly that. I got the feedback pretty early. Automate tests. Well, that's pretty simple, but all type of tests. Unit test, you can use group, integration test, UI test, deployment test, system test, and so on. That's important. Deployment test. In deployment test, I mean 2 things. Test that you can build and you have described it correctly, your environment, and you can provision it correctly. And test that all your systems that you require are there, are installed correctly. Let's imagine that you are developing a new cool application using MongoDB. Well, one pretty simple test, deployment test, is to check that the MongoDB service is running. So here, if you have some production guys say, yeah, it's Nagios. Nagios is doing that for me. Integrate it. Integrate it that if you provision your system, that everything is running correctly. System test is, well, once it's deployed, checking that your system is really working correctly. Automate deployment. Again, everything needed to be automated, so the deployment too. So describe your environment. Always deploy the same way. That's really important. How many people are running their own Tomcat or whatever on their own machine, which is a complete different version of what they used in production? Because believe me, in production, they are not using the latest cool Tomcat with the new NIO system. No. They're using Tomcat 5. So for that, you say, well, it's hard because I'm not using the same operating system. I'm not using the same way of deploying. For me, I have Eclipse on my IDE. I just do debug, and then that's it. Yeah, actually, yeah. But in production, it doesn't work like that. So you may have issues that you cannot discover because you are not really using the same deployment way. I don't say that what you are doing is bad. You should do it. But before being sure and say, well, I'm done, really deploy the right way. You say, yeah, but I don't have the production system. But today you have a lot of cool tools for that. Vagrant. Who used Vagrant or already used Vagrant? Oh, not that much. Vagrant is a tools on the top of VirtualBox, which is an Oracle product that they bought from Sun, which virtualization system for your desktop, where you can describe and script a VM. And then you can deploy using Puppet or Chef or a shell script, and it works really, really well. So I have right now, I don't know, maybe 10 or 15 different Vagrant boxes on all my projects, and it's production-like environment. So I have my project, I build it, I test it, I'm pretty happy, but I will just try to deploy it using the same deployment script on my Vagrant VM and check that it's still working. Even better, if you have this, a complex system using MongoDB and so on, then you can use exactly the same system to avoid people installing their own version. Just do some port forwarding, Vagrant supports that, and that's it. So if it hurts, do it frequently. And generally deployment hurts. So it's better if you do it every time day. Manage configuration, okay? Test. And plan rollbacks. That's pretty important. Everything you do must be able to be rolled back. And this is really, really hard, especially for data migration. There is no really big, cool tools for that. Maybe Liquid-based is not bad, but well, something that you need to plan beforehand. Implement a test strategy. So let's imagine that it's our pipeline. Acceptance test, UI test, and so on. You commit a first version, boom. You commit a second version, oh, acceptance test, boom. Well, it's normal. Maybe you failed something and so on. You did a third version, then this third version crossed the complete pipeline and is release ready. It's really important. So you have V1, V2, V3. How it works, so really, it's quite simple. You have your source repository. The first step is what we call commit stage. It's a Maven clean install, it's a make, and so on. So it will just create a version, V3, and then inside a binary repository, it will deploy it, and then all further tests will use this version till the promotion or release stage, which means we are ready. We can cut a release, we can give something, or even better, it might be deployed. So the commit stage is mostly the one of the most important. It must be really fast. And it will do a lot of things, so package, changelog, scripts, and so on. So depend on your project, but you may have this correctly. One rules, build only one distribution. Distribution is a package where you will have your configuration, your deployment script, everything in one. It's really important because then you know what you have, and you have only one thing to download. And this package will be used by all the test phase. This package, nothing else. We don't rebuild it. If you are redoing a Maven clean install, well, something gets wrong. Describe your environment. Puppet, Chef, Vagrant, or whatever. There is no plenty of tools to describe your environment. Are they good? Not necessarily easy to handle at the first place, or yet, but do it. Seriously, it's better than you have a manifest, you have a file, and everybody can discuss and say, hey, if we change that, and so on. And this is only one goal, is to reduce the distance between your development environment, your laptop, and what is really happening in production. Always deploy the same way. With Vagrant and so on, now it's possible. Okay, back on our project. So, in terms of SCM, I use all of those, and it never failed. Build tools, I'm generally using Maven. So you say, well, how do I manage snapshots? We'll just see. I use a specific plugin that I did. It's continuous versioning Maven plugin, plus the Maven release plugin. I will explain why I'm using that. And I use Jenkins, Nexus, and yeah, so, and well, you probably have somewhat the same kind of environment. You just change the different technologies. So in terms of development, remember, developer doesn't want the way they work, so use snapshots. Wow, but we say that we don't want snapshots because it's not reliable. Yeah, but actually they are used to snapshots and they want to use snapshots, so, well, we will see. And use Vagrant, because the work on my machine is something that today it's too expensive. So Vagrant will help you to avoid that. I just discovered Vagrant 2 months ago, and since I'm really using everywhere, it's really impressive what they did. So with Vagrant, you can provision your system using a shell script, Puppet manifest, Chef recipes, and so on. And you can execute those one on your computer. Well, it's your deployment script. So the deployment script is not something that only the operating guys can use and can execute. You can do it too. And that's really interesting. So how does that work? Commit stage. So I do a Maven clean install. I have a 100 snapshot. It doesn't go to the artifact repository because there is a snapshot. Then I have something called a fast release, which is which computes a unique number, build number, That's underscore 42. Cut a release out of that and go in my artifact repository. Or I compute this number. That's pretty simple. You are using SVN, take your revision number. You are using Git, compute the number of commits you have in the current branch. It's always increasing. It's simple. Actually, you can do the same thing on SVN. But, well, in SVN, we are used to revision. The plugin, the continuous versioning Maven plugin is doing that for you. So it will compute it, prepare the release, and you have nothing to do. So now that means that all further tests will use the 42 version. So that means that if you get the tag, there is absolutely no snapshot inside. It's reproducible. But for the developers, it doesn't change anything because they're used to snapshot and they have snapshot. Why underscore? Because if you take the versioning, the ordering of Maven version, this is a really weird character. You need to read the algorithm to understand that, but when I discovered the algorithm, I said, okay. The plus and the underscore have different, and the exclamation mark, doing some interesting weird thing. But the good point is 100 is superior to 100 underscore 42. 100 snapshot is superior, is greater than 100 underscore 42. So that means that you can still work and you will use your own version and so on, and you won't get any problem with this. So that's why we are using underscore for that. Okay, testing stage. Well, integration test, then we generally create a background box or whatever. We do the deployment, we do all the UI on that one. Don't forget that we have the 42 version deployed. Then we continue. We do the same thing on a real staging system, so on a real host. That one is a VM. So if something goes wrong, it's not a big deal. We can just crash it and restart it from scratch. And here on the staging system, it's a real system, so you need to be more careful. That's why we do that on a box before. You need to be sure to do something that works when you arrive on a live system, because if you have to connect and to repair it, it's kind of bad. And so on. So the releasing, actually, if you really do continuous delivery, you will do promoting. That means you take the current version, and instead of cutting a release, you will just say, well, this was my release candidate, and now I declare it global availability, the GA. GBoss, Red Hat, and so on are using this. It works, and you don't have to rebuild it. You have a live system that works, you're happy with that, you just say, well, it's my release. So tooling quickly, you will have the slide. So any Vagrant is awesome, but you can use VirtualBox or whatever, if depend on what you have and on your project. I never tried Travis, so I don't know. That's why it's not on the same line. But I did it with all of those, and I never had any issue. Actually, the latest Bamboo has pipeline support natively. In terms of configuration management system, well, Shell, Puppet, Chef, whatever, Yat, now you have plenty of tools, just use them. They're not easy to learn, but treat your infrastructure as code is really good because you can test it. For your application, you can use whatever you want. So Yat, you will do it. You can use it Puppet 2 or mCollective, or if you're in the Java world, don't forget GMX. It's old. It's pretty old, but it works really well, and it's not used enough today, I think. That's it. If you have the need to go to continuous delivery, then try to do it right, because it can be really a nightmare, and you need to be sure that your developer understands the new responsibilities they have. It's not an additional task, it's just making things a little bit clearer and more robust. Follow the rules, never shortcut the pipeline. Never. One of the good aspects is the trusted back. You trust your project because you see what you are changing, and the customer or the product owner see that you are really working. It's unbelievable the number of people saying, well, but my teams are just spending their time on Twitter or playing to the latest cool games on Facebook and so on. Well, actually, they're working. Just like check the SVN log and you will see that they're working, but yeah. Then you see the change, so it's really good for motivation and for the trust. And you always been ready. You always have something to show. You always have something that you can deploy in production, and you know where you are. Even if your team is 60 people, you know exactly where you are, and this is pretty important. And the last point is track and visualize everything. Then it's more those dashboard-like kind of things. Use Graphic, use any dashboard system, but check exactly where you are and what you do. You do a release, write it somewhere. You do deployment, you have a log explosion, write it somewhere. That's it. Thank you.
Okay, I think we'll give about 1 minute or two for questions. Anybody?
How does continuous delivery fit to Scrum sprints?
That's an interesting question. I mentioned it at the beginning that I was using Scrum. Scrum has this sprint iteration model, which does not necessarily fit really well with continuous delivery, as you are delivering several times a day or anyway. What I saw so far is when you are starting doing continuous delivery for business reason, then your development model change and migrate in a mix between Scrum and Kanban, which is a bit better, or at least it fit better. So it will be a mix. Anyway, never trust such kind of methodologies per se, and it's not a Bible or whatever. Adapt it for your need. So if you really want this, then Kanban will fit a little bit better, but you still have to adapt it to your team. Those processes need to be done for your team, depend on your size and so on.
Anybody else? Okay, thank you.